This is a demonstration of the J-KEM Titer machine. You first would simply take your sample and you'd put it inside of the Titer cell. There's a stir that goes in the sample. Tighten it in position, place the cover on, and then put your temperature probe into the sample. You can see that the temperature of the sample in the upper right hand corner is continuously displayed. You can select the chemist who is running the test, the name of your test material, and when you load that in there, the important parameters for the Titer test are entered. And then any sort of a comment that you want to enter, you can do so. When you're ready, you just simply click the Start button. And the very first thing that happens is this material, we expect that the Titer point will be at about 5 degrees centigrade. And so what we're asking the test to do is to start at 16 degrees centigrade and then cool. So the first thing it is going to do, it's going to cool the sample temperature to the start temperature, which is 16 degrees. I can tell it to continue at this point. And you can see when I tell it to continue, the Titer machine starts to stir the sample. We're stirring it now because we get better mixing, faster cooling of the sample. And then when the sample temperature gets down to the start temperature of 16 degrees centigrade, the actual Titer test will begin. Now in this plot, there are going to be two lines. There's the blue line, and that would be the upper one. That is the temperature of the sample. And then the green line is the temperature of the cell. The important thing in a Titer test is to make sure that energy is withdrawn from the sample at a constant rate for the entire test. And so that's why there's a temperature differential between the sample and the cell. And the cell will update its temperature so that it's always exactly 5.0 degrees centigrade below the sample temperature. And in that way, you're going to control the cooling rate. Okay, the test has been running for a while, but now we're going to begin to approach the Titer point. And as you can see, as I said earlier, the blue line is the temperature of the sample, and the green line is the temperature of the sample cell. And we control the temperature of the sample cell, maintaining it always exactly 5 degrees centigrade below the temperature of the sample, which assures a continuous, even, uniform rate of energy removal from the sample, which is what you need to determine a Titer point. So during this entire time, again, the teeter machine has been continuously stirring the sample. Now, when the teeter point approaches, what happens is when the software senses that the slope of cooling is approaching zero, at a certain point, when it gets to zero, the stirring will stop and the stir bar is removed from the sample to allow the sample to crystallize and obtain the most accurate teeter point possible. And now we're approaching that point right now. So it's going to hit right now, and when it does, you'll see that the stir pulls itself out of solution, and the test continues. And at this point, because it saw a slope of zero, the graph expands so you can more accurately see when the teeter point is hit. You can see the software knows that it has found the teeter point, but it will continue to collect data for about another minute. At this point, it found the teeter point, and it's telling you the temperature, 5.12 degrees centigrade. Now what happens is the sample begins to heat because the sample has solidified, and you wouldn't be able to get the temperature probe out of it or the stir. So now it's going to heat to its starting temperature, and then once it's heated, once the sample is melted, the software will tell you. So I'm going to pause for just a minute while the sample heats. Okay, the sample's been heating for a while, and as was said earlier, it's going to heat to the start temperature, which is 16 degrees. That will assure that the sample is completely fluid. So when the sample temperature reaches 16, this message right here tells you that it's melted. You can remove this stir. If you wanted to do another run, you could simply tell it to reset. Now all of this data has already been written to Excel. When we do successive runs, you could run the same sample 5 times in a row and you would get the same Titer point, generally within 3 or 4 hundredths of a degree centigrade. And so the value of the Titer machine is that it is 100% reproducible. It takes out all of the human variation in a Titer test, and just simply by the click of a couple buttons, you can run the tests with highly reproducible results. Thank you.